everyone. On behalf of State Council of Science, Technology and Environment, I would like to welcome all the viewers, especially the class 10 student on this online coaching class. I hope this class will be very helpful for you all. So today I am going to teach you all about a very important topic, and that is about triangles, which is taken from chapter 6 of class 10 mathematics textbook, which is prescribed by MBOSE. So before starting with the class, I want you all to visualize some of the objects that you can see in your daily life which has three sides. Alright, so for example, there are many food items or food materials which has three sides. For example, the bingo chip that you always eat, that also has three sides, and some other also. Also you can see the reflector signboard on the roadside, those also has three sides. Alright, so there are many objects that you can see around which has three sides, and these objects which has three sides, in mathematical term they are called as triangles. So today we are going to learn about triangles. We'll learn about triangles. Alright, so we already know triangles has three sides. Triangles are those closed figures which has three sides or bounded by three line segments. So under the chapter of triangles, we will try to understand about the concept of similar triangles. But before doing that, let us try first to understand the concept of congruent figures. We'll do about congruent figures. Congruent figures. Alright. Right now, I have with me two squares. So when we observe at these two squares, we can see that they are exactly of the same shape, right? Yes, they are of the same shape because they have the same angles, that is 90 degrees. And now let me overlap these two squares together. So when we overlap them together, we can see that they are fit exactly with each other. Alright, so it means these two squares have the same shape and have the same size. Their sizes are exactly the same. Alright, also now I have these two triangles. When we look at these two triangles, again these two triangles are of the same shape because they have the same angles. Alright, here angle A is equal to angle B, angle B is equal to angle E, angle C is equal to angle F. And now again let me overlap these two triangles together. When we overlap them together, we can see that these two triangles also fit exactly with each other. So it means these two triangles have the same shapes and also the same sizes. So there are many figures around you which have the same shapes and the same size. All those figures which have the same shape and the same sizes are called as congruent figures. So in here, for example, you have triangle ABC, triangle A, B, C, we name it as ABC, and triangle D, E, F. We have already understood that figures are said to be congruent if they have the same shape and same sizes. Alright, so it means these two triangles, ABC and DF, are congruent if they have the same shape. It means here angle A must be equal to angle B, angle B must be equal to angle E, angle C must be equal to angle F. And the next point, the first thing is that angle A equal to angle D, and then angle B is equal to angle E, and angle C is equal to angle F. Right? And the next point, they must have the same sizes. It means here the corresponding sides of triangle ABC must be equal to the corresponding sides of the triangle DEF. Alright, so it means here the second point, AB must be equal to the side DE. Next, side BC is equal to the side EF, and side AC is equal to side DF. So whenever you have two figures having the same angles and the same sides, they are called as congruent figures. In mathematical term, we write triangle. In mathematical, we'll write triangle ABC is congruent to triangle DEF. Right? Now, having understood the meaning of congruent figures, now we'll try to understand the meaning of similar figures. The next point is about similar figures. Again, now have a look at these two triangles. These two triangles, again, they are of the same shape because they'll have the same angle. Alright, here angle P will be equal to angle D, angle Q must be equal to angle E, and angle R is equal to angle F. But now, are they of the same sizes? Let us overlap. When we overlap, it doesn't fit, right? These two triangles does not fit with each other. So it means these two triangles are not of the same sizes. Alright, they are only of the same shape, but they are of different sizes. And next, again, you check at these two squares. These two squares also have the same shape, their angles, because their angles are the same. Again, let me overlap. They doesn't fit with each other, right? So it means these two squares are of different sizes. They are of the same shape, but they are of different sizes. Alright, so whenever you have two figures having the same shape but different sizes, they are called as similar figures. So don't get confused with congruent figures. In congruent, they have the same angles and same size, but in similar will have only same angles but different sizes. Right? So here we'll have similar figures are those figures which have the same shapes but different sizes. Alright, now after we have understand the meaning of similar figures, let us try to understand the meaning of similar triangles. We'll have similar triangles. Similar triangles. It is exactly the same with the similar figures. Similar figures means they have same shape but different sizes. Similar triangles also, it means they have the same shape but different sizes. So in mathematical terms, we can say two triangles are said to be similar if they have the same angles or their corresponding angles are equal but their corresponding sides are proportional. So look here, suppose I have triangle A, B, C and triangle D, E, F. Right? These two triangles are similar if their corresponding angles are equal. It means angle A equal with angle D, angle B equal with angle E, and angle C equal with angle F. Their corresponding angles are equal. We'll have angle A equal to angle D, angle B equal to angle E, and angle C equal to angle F. And the next point is that their corresponding sides are proportional. Here the corresponding sides of triangle ABC are AB, BC and AC. Corresponding sides of triangle DEF are DE, EF and DF. When we say their corresponding sides are proportional, it means the ratio of their corresponding sides are equal. Their sizes are not equal, but the ratio of their corresponding sides are equal. So here side AB correspond with the side DE. Will have, second one, we must have AB by DE is equal to BC by EF and AC equal to DF. The ratio of their corresponding sides are equal. All these are equal to one common value, let's say K. Right? So this K here is called as the scale factor. Alright? So now I believe you have understand the meaning of congruent figures, similar figures and similar triangles. The next point I am going to prove about a very important theorem, Thales theorem, which is proposed by the Greek mathematician Thales. This will do with triangles. If a line is drawn parallel to one side of a triangle, right, intersecting the other two sides at distinct points, then the other two sides are divided in the same ratio. Alright, so this is the statement of the theorem. It states that if a line is drawn parallel to one side of a triangle intersecting the other two sides at distinct points, then the other two sides are divided in the same ratio. So let us split from here what are given to us. We see if a line is drawn parallel to one side of a triangle. So it means we are given a triangle. First we must have a triangle. Let me draw a triangle here. So let us name this triangle as triangle A, B, C. So what happens to this triangle? A line is drawn parallel to one side. You can draw parallel to any side, alright? Either alongside AB, BC or AC. You will draw one line parallel to one side. So let us take it along the side BC. We draw a line parallel along this side. So we'll draw a line. Alright. What happened to this line intersecting the other two sides at distinct points? So this line meet the side AB at this point and the side AC at this point. So these 2 points are different. So let us name this point as point B and this as point E. Right? Now, what happened next? Then the other two sides are divided in the same ratio. That is that we are going to prove from here to here. Alright? We are given triangle ABC and then line DE is drawn parallel to the side BC, meeting the side AB at point D, and the side AC at point E. That we have to prove. Sorry, that is given to us. Then we have to prove that the line divided the other two sides in the same ratio. It means AD by the ratio of AD by DB is equal to AE by EC. Right? So now let me write first what is given to us. We are given triangle ABC in which DE is parallel to BC and then lines DE meeting, also DE intersect AB at D and AC at E. This is given to us, and next we have to prove the ratio are equal. So we have AD divided by DB must be equal to the ratio AE by EC. Right? Now to start with the proof, we have to do one construction, and that is we will join D with C. Right? We join BE and DC. Next, draw a line from D in such a way that it perpendicular to the side AC, perpendicular along the side AC, and from E perpendicular along the side AB. And let us name this point here as F and G. Alright, these two are our construction. First we join D with E and then D with C. Next we draw DG perpendicular along AC and then DF perpendicular along AB. So this is our construction. Draw DG perpendicular along AC and then EF perpendicular along AB, and next join DC and DE and BE. Right. Now we'll start with the proof. Alright. So to start with the proof, let us break this big triangle. Here we'll take the first triangle ADE. Alright. Triangle ADE. This one. Let me change it to E, D and A. And next take triangle BDE. BDE. This is an obtuse angle. Alright, greater than 90 degrees. We take triangle BDE. So it is something like this. Right. So this is D, this is E, and this is B. Another triangle. Take triangle CDE. This is also an obtuse angle triangle. So this is CE and then So from this triangle, first we'll take triangle ADE with triangle BDE. Alright, take triangle ADE with triangle BDE. After that we'll take triangle ADE with triangle CDE. Alright, so in here you need to understand that we will use the area of triangles. Right. So before that, what is the area of triangles? The area of triangle is half base into height. Right. So when you take triangle ADE, so this is the one, ADE. So we can see from D we draw one perpendicular line, EF along the side AD. Right. So this is a perpendicular line, EF along the side DA. So it means this is the height of the triangle. Right? EF represent the height of the triangle ADE and DA represent the base of the triangle. Right? Next, when you take to this obtuse triangle BDE, when you take this one, this is a triangle. How to get the height of this triangle? What you will do, you extend this side along this side DE, you extend it this way. Then from B what you will do, you draw a perpendicular. Alright. So let me do this. This is along B. So let me do this is, let us change this to E and this one to D. Alright. This is D. Sorry. And this is E. Alright. So you drop this perpendicular here and then we'll name this as F. Okay. You only have to interchange this in this way so that we can see clearly what is the height. Alright. So this is the height EF and this represents the base DB. Okay. And the next one, you take this triangle CDE. Triangle CDE, again you extend the side CE this side. What happened? Then from D you drop a perpendicular. We name this as G. Right. So here DG represent the height of the triangle CDE and EC represent the base. So having understood how to list down the height and the base of this triangle, let us take the ratio of triangle ADE with the ratio of the triangle BDE. Right? So here, proof. First we'll concentrate with this perpendicular EF. Right? Since EF is perpendicular to AB, alright, so then what will we have here? EF will be the height. Alright, so thus let us take the area of triangle ADE by area of triangle BDE. So first, what is the area of triangle ADE? It is half base into height. Half base into height. This is half. So what is the base? The base is AD. Half AD into height. The height here is EF. So this is EF. And next, again area of triangle BDE is half base into height. BDE, what is the base? The base is BD. Right? So we'll take that. B, D. And again the height is, the height here we have EF. So from here we can see that half and half get cancelled. EF and EF get cancelled. Then we'll have AD by BD. Mark this as equation 1. Alright. Now, so this is the first equation that we have. Let me rub this.
Thus, area of triangle ADE by area of triangle CDE. Alright. Now in this case, we will take DG as the height. Alright, if you feel you are confusing with this, we'll change that into this. So this is D, this is E, and this is E. So from D you draw a perpendicular along EA. So we name this as G. Alright, so in here, what will be the height? The height is GG and the base is EA. Alright, so the area of triangle ADE will be half base. The base here is DG. Sorry, the base here is AE and the height is DG. And next, half area of triangle CDE. This is the one, CDE. This is the height and this is the base. Half base. Base is EC into DG. EC into DG. Again, half and half get cancelled. DG and DG get cancelled. We'll get AE by EC. We'll mark this as equation 2. Alright. So, look here very carefully. Side DE is parallel with the side BC. Alright. Side DE is parallel with the side BC. And on these two sides, we have two triangles. Triangle BDE and triangle CDE. These two triangles, they share the same base. Right? They share the same base. It's like two lines are parallel, and from this line, suppose we take this as the base. Alright, so from here, you get one triangle. Right? And again, using the same base, you get another triangle. So, we can see these two triangles, they share the same base and between the same parallels. So, there is one property which says that triangles sharing the same base and lying in between the same parallel, their area are equal. So, here we mean to say that area of triangle BDE is equal to the area of triangle CDE. Right? But area of triangle BDE is equal to area of triangle CDE. Right? Since they have the same base and between the same parallels. Alright, so then next what will we do? We'll take the ratio. We'll take the ratio of these two triangles. Then we'll get 1 by area of triangle BDE is equal to 1 by area of triangle CDE. And again, we will multiply from both sides by area of triangle ADE. Alright, multiplying both sides by area of triangle ADE, then this will be area of triangle BDE is equal to, we multiply both sides by area of triangle ADE by area of triangle CDE. Right. So when we observe at these two equations here and have a look from equation 1. Equation 1 we have from the left hand side area of triangle ADE by area of triangle BDE. Equation 2 we have area of triangle ADE by area of triangle CDE. From here we see that these two areas, alright, these two ratios here, they are equal. So it means that AD is equal to AD by DB is equal to AE by EC. Alright. Here we have the proof of the theorem. Hence, we get that AD by BD is equal to AE by BC. Alright, this is the...
Alright, I hope you have understood the proof of the theorem very well. So, in the next class, we will solve some problems by using Hill's theorem. So, till that time, thank you.